Okay, class, welcome back. Part two, electrical. I took a little break there, wet my whistle, went and got a little more tea, and I'm not doing any subliminal. Just saying. There you go. Before it's over with, you'll be hypnotized. You'll be a K-State fan, even if you aren't. If you're a KU, you'd still be seeing this. Eventually, you're going to become a K-State fan. So here we go. Electrical part two. Let's get going. Okay, this is where we left off. We left off with the coffee pot, galley power. We're shedding it, right? And I don't care if we're shedding the galley power because I don't drink coffee. Now we're into part two, the electrical system on the CRJ 700. General information, electrical sources. So the CRJ has two main generators, integrated drive generators, integrated drive. Remember that, integrated drive, IDGs, IDGs, IDGs. Get these acronyms into your head because this is what you're going to hear for the rest of your career. And they are powered by their respective main jet engine. Each IDG is made up of a constant speed drive, and that's called a CSD, and the associated AC 115 volt, 400 hertz generator. The APU and its associated AC generator, also 115 volts at 400 cycles, can independently produce the required electrical output to meet all of the aircraft's electrical needs. So think about that for a second. I didn't say that with the engines on the generators on the main engine, did I? They're not quite as hefty as the APU generator. The engine generators are mounted to the engines. We want to really use as little electrical power as necessary to keep the aircraft flying when we're running the engines, because we want those engines to produce thrust, not so much electrical. On the other hand, the APU, we don't use for thrust at all. We can produce as much electrical power out of that without affecting the flight performance of the aircraft. So that's kind of why the APU actually has a more hefty generator on. External power can be plugged into the side of the aircraft when it's parked at the gate. Couple different ways of doing this. Of course, we can use a GPU, or we can just plug it into the main source coming off the building or jetway. Then we'll have another source. It's an air-driven generator. We call that an ADG, and that is a backup-driven generator that can be deployed in flight to provide power to critical electrical buses. Now, this is really a situation where you're down to nothing but the ADG. So if you have an APU running, or if you have an engine generator or both engine generators running, you're not going to deploy the ADG. It's an emergency device. In addition to that emergency device, you have two 24 volt DC NiCad batteries that are connected to the DC side of the electrical system to provide emergency DC power in the event that your normal AC power is lost and cannot be restored. Okay. Now I say they both provide emergency DC. The reality is one provides emergency DC, the other battery is for starting the APU, which is kind of a way of saying, hey, if I'm out of my engines aren't running, or my generators on my engines aren't running, maybe we do need to start that APU to get normal ship's power back. So in that case, I'd call that one a 24 volt DC emergency APU battery to get my APU back home. So there you are. That's your sources. Again, let's repeat. Two engine-driven generators, an APU-driven generator. All of those produce 115 volts at 400 cycles. And then we have a backup air-driven generator, which can power some of the critical buses. Then after that, it's emergency power on batteries. The IDG electrical power, this is AC, alternating current. When both engines are running, their respective generators, 1 and number 2, provide power to the AC bus number 1 and AC bus number 2 when their associated relays are closed. We'll talk about that. AC bus number 1 provides AC power to the AC essential bus. When one IDG is taken offline, the remaining IDG will power its respective bus and can power the opposite side bus when selected to do so. So let's talk about this. Oh, there's my pin. Okay. So right now in this scenario, let me see if I can move my face out of the way here. There we go. Right now in this scenario, the engines are powering up their respective AC bus. We have engine generator number 1 with its relay closed. That brings power down to AC bus number 1. Likewise, generator number 2 with its relay closed is now powering up its associated AC bus number 2. In the event that we lose this generator, just goes offline for some reason, this bus would open and this bus would remain closed. This relay would close and this relay would close, providing power all the way across to AC bus number 1. So this relay would be not in service. That's how we can power the opposite side with generator number 2 only. The same happens if we just had generator number 1 and did not have generator number 2. The reverse is opposite, applies. So that's what can happen if you lose a generator. Of course, one generator probably wouldn't be enough to power up all the buses. So at that point in time, we might want to think about doing some load shedding. Get rid of that coffee and go to tea and with just some hot water. Okay. Good. That's out of the way. I think we can move on. And now we decide what are the other alternate sources of power. In this case, the APU's generator can provide power. The APU's generator can provide power to the aircraft electrical system by powering both AC buses number 1 and number 2 at the same time. And we don't have to even do any load shedding. That APU generator has got enough punch to it to run the whole electrical system on the aircraft. Like the APU, external power source of AC power can be used to power the aircraft electrical system. Because it's ground-based, we don't care what the weight is. It's got plenty of power to run the entire electrical system by itself. In flight, the ADG can provide power to the ADG bus and then will power the AC essential bus when other sources of power are lost. So let's just zoom in here a little bit, get up to this one. As you can see, we have the APU generator right here providing power. Its associated relay is closed, providing power to the electrical crosstie circuitry. Each relay on each side is closed and now provides power to each AC1 and AC2 buses, at which point AC bus drives the AC essential, and AC bus drives the AC service. So we can power up the whole thing, of course, then at that point we can start powering up our TRUs. All right, let's see. Likewise, if the APU is not running, we're parked at the gate for some reason for an extended period of time, we would run the electrical system with external power cart here. It would come down and its relay would close. And just like the APU, we would supply power to the AC bus number one, AC bus number two, at which point power is redistributed on throughout the system to other AC buses and eventually to the DC side through the TRUs. And finally, another source of electrical power. Let's say for some odd reason, we have a dual generator failure in flight. So we lose both of our engine generators. And for some reason, the APU didn't get started, or we took off with an APU that was inoperative, MEL'd out of service, so we could do that. But now all of a sudden, we find ourselves without any source of AC electrical power. When we lose all other sources of AC electrical power, then the emergency ADG, air driven generator, would pop out of the side of the aircraft. The generator would begin to rotate because of airflow through the propeller that's attached to the ADG generator. It's going to end up powering the ADG bus. ADG bus is going to power up the essential bus, and the essential bus is going to come down here and power up the essential bus TRU number two. So we have whatever was all the items coming off of the essential bus would be powered, and we would get some DC stuff that was uh, needed to be powered, and we would be able to continue the flight of the aircraft at that point in time. So there you are. That's how important that ADG is. We don't want to fly this airplane without electrical power. Okay, that's all I got to say about that. And let's move on. So we haven't talked a lot about them. We mentioned them. TRUs, transformer rectifiers, convert AC to DC. Really important on this jet. This is the way it works on a lot of jets. So let's talk about it in a little more detail. AC bus number one and AC and two and AC essential bus provide power to 4 TRUs. So we got this bus, powers TRU number one. The other bus over here powers TRU number two. Essential AC bus powers up the essential TRU number one. And then AC bus number two produces power to be converted to DC power through the essential TRU bus. And what's it do? It converts AC power to 28 volts for the use of DC buses. Now, I know you're asking, I said earlier 24 volts for the batteries. That's a nominal power, okay? So it can range a little bit between 24 and 28. So in this case, the TRUs are producing 28 to push some power into the batteries and into the buses where they need to be used, where it needs to be used. So that's what the TRUs do. Remember, they convert AC power to DC power. What kind of AC power? 115 volts, 400 cycles. That's what they convert to 28 volts. Electrical control. So here we've gotten rid of the the flight engineer. So think about it this way. Computers are taking over. Now we're coming out with artificial intelligence. Oh no, that's going to take away the pilot's jobs too. Well, not quite yet, but computers have taken away the job of the flight engineer. Now the flight engineer gets to go up front when his number comes up, and now he can help fly the airplane as opposed to just operating the systems that keep the airplane flying. So how did we do that? We've replaced the flight engineer with a uh, DCPC, two of those, and an ACPC. So to help manage the electrical systems, the CRJ uses an ACPC and two DCPCs to make sure the appropriate buses are powered. These are basically computers that open and close the switch relays in each of the AC and DC parts of the electrical system. So these are your flight engineer. Rely on them because if you don't, you're going to get behind the eight ball trying to keep up. Of course, this shows the location. DC power uh, center is near the cockpit, and AC is more towards the central location. Not that it matters at all. So, control and monitoring. So let's take a look at what we got here. Let me go ahead and zoom in on this. We'll start with this side. And, oh, let's see, this device right here, this panel. Of course, these are way enlarged compared to the flight deck. That panel is actually the external panel. It's located on the outside surface of the aircraft, recessed slightly. Probably has a door over it, no doubt. And this is where you control the external power from. So as you can see, you have external power push. You're going to see a symbol. Now this is stuff the ground crew is looking at. So I really don't care as a pilot, other than when I do my walk around. I'm going to want to see maybe external power in use or external power available on that. And if the ground crew wanted to talk to the cockpit, they'd push this cockpit call push. You get a ding dong, and we'd pick up our headsets and we'd be able to talk to the ground crew on that. We have an emergency APU shutoff switch here. That's always good to know. And lamp test. And this is where we plug in our headsets, I guess, if you want to talk to the mic. So this controls right here whether or not we've got power available from an external source. Over on this side, this panel here, this whole thing, that is this panel right up in this area right here. This is the electrical power control panel. Now you'll notice that it has says master switch right here. I want you to think of that as being just like the master switch on your Cessna 172 or whatever light aircraft you're flying. So the master switch basically turns the battery on, puts the battery online so that we at least have some DC power available to the DC side of the aircraft. When we have external power plugged in, you're going to see it right here. It's going to say available if it's plugged in. And if we push on that button, it will not only make it available, it will put it in use. So we'll have external power actually on the aircraft. So now we have AC power available, powering up all the buses. Then we have a IDG number 1 disconnect switch. You notice that it's covered. Same thing over here, IDG number 2 is covered. So for us to disconnect the IDG has got to be an intentional thing that we want to do. We're just not going to blindly reach up there and turn those on. We actually have to physically move the cover to disconnect those IDGs. So that's a disconnect switch. Right here is the number 1 generator switch, and that's an off or reset switch. Generator number 2 is right here, number 1. And then we have the APU on, off, or reset switch right here. Okay. And then we have the auto transfer. So this is all stuff you would look at if you were had an issue with your APU or with one of your generators. You would get the QR if you're in flight. You get your QRH out, and then the QRH will basically tell you which one of these switches to flip. And if you understand the system, it'll make sense as to why it's telling you which one to flip. Okay, let's move over to this panel. Now, what we're looking at is ICAS number 1 panel, or correction number 2. This depiction right here is of the AC electrical system. How do we get to this page? We would push the electrical button right here. Now this whole panel right here is located right down here in the cockpit. So it's real handy. You're going to be pushing these buttons all the time to see what's going on on different systems. Like if I want to look at the fuel system, I would push the fuel system button. If I want to look at the electrical system, I would push the electrical button. Once I'm done looking at it, I would generally go back and press this status button to take me back to what I would consider the normal view for general system information. Okay, we got a lot of different things on this panel. We got flight controls, which would show us a depiction of the aircraft, ailerons, elevators, trim positioning, that kind of stuff. And of course, if we want to look at doors, it'd be over here. Know if the doors are open or closed before we push off the gate. That's kind of the information you find. Here's another big one, hydraulics, and then you have the environmental control system right here, ECS. But this is what we're looking at right here, the electrical page. Now, if we push this button twice, it takes us to the DC electrical page. So whenever we push that button, we're first going to get the AC picture, and then we push it again, we get a DC schematic. Generator control, the GCU. Now, we talked about the brains of the operation, the PC, let's see, AC, PC, and the DC PC. Those are kind of the brains. They operate the relays, switch sources back and forth from one generator to another. But the generator also has its own electronic brain, so to speak. Each generator is controlled by a GCU, a generator control unit, whose functions include controlling the generator's frequency and voltage, protecting the electrical system from overcurrent and differential current faults. And when the GCU determines that the generator is providing electrical power that's within limits, really close to 115 volts, 400 cycles, the GCU will close that main generator's relay as required to place the generator power online. So that's what we mean right here when we're talking about a GCU. It's the brains of the generator, but it is not the brains of the electrical system. So it just simply talks to, in this case, it's going to be talking to the AC PC and saying, hey, I've got available power to you, all looks good. Whenever you want it, you can go ahead and switch around the relays as necessary, and you can bring me online when needed. So that's all it's saying. It's kind of a buddy of the ACPC. And again, as a review, what do you call this whole thing? IDG, integrated drive generator. Constant speed drive and a generator combined equals IDG. Now you ask, what happens if I have all my sources of power available and I have the computer running the system for me? What's going to power what? So here's the easiest way to explain this. Here's the AC priority, power priority. Only one, and you got to remember this, only one source of AC power can be connected to the AC bus number one or bus number two at a time. Only one source. You can have a generator supplying power, generator number one supplying power to AC bus number one, and number two generator on the other engine powering to number two. Or you can disconnect the power from AC, the generator number two, and you can now attach the APU generator to that bus number two, or vice versa, same thing over on generator or on bus number one, but you can never have them on the same bus at the same time. That would completely mess the electrical system up. So when the AC power is being produced by all generators or external power, the following priority applies. Now, this is with the exception that the ADG is not in consideration in this scenario. So typically the ADG is not going to be running at all, right? Unless you're in flight and unless you've lost all your normal ship's power. All the other sources of AC power are not of any of them are none of them are available. So that's why we aren't applying the ADG to this scenario because it wouldn't be in use anywhere. So if you had the on-site generator running, you had an APU generator, you had the off-site generator and external power, you have all your generators running, what's going to power what? Well, let's take a look. I believe that'll get us there. Okay, so if you have all running, the first thing that's going to occur that the on-site main generators are going to power its respective bus. So let's take a look. We've got this engine running, number one, and number two engine running, along with the APU, except the APU is not going to be used at this point in time. The power that's going to be used is going to be from this engine going up to its respective bus. Number two engine's going to go up to its respective bus and power that. And then it's going to go to that bus and that bus. And in this case, engine number one's going there and then to this bus and then to this bus. That's the order of priority. So we can think of it as the engine generators providing power to its respective bus. Let's say we take this engine out. Then we move over to this slide, and this engine's not operating, or at least the generator's not operating. In that case, if the APU is running, it will automatically connect up and come over and power the AC bus number one, and therefore the central bus and that bus. And then number two would continue to power the same buses it had been powering. Make that clear? Good. Moving on. Let's move to the other side. If you were to lose both this engine generator and the APU generator, at that point in time, the number two engine, for example, the offside generator would come across and power AC bus number one, and it would continue to power AC bus number two. If you have external power plugged in, and that's where we show external power right here, then it would power that external bus. And of course, then if you took all of these offline with AC power plugged in, AC power then would provide electrical power to all of the buses necessary to provide electrical power throughout the area. That's the order of priority. So if somebody asks you, you would say, well, that's easy. It's going to be on-site generators first, APUs next, off-site next, external power. Just answer the question that way, and you'll be good enough to go. Now, we talked a little bit about the ADG. Here's what the ADG is. It's that little fan thing that pops out of the side of the aircraft. It's that little fan right here that pops out of the side of the aircraft. And you'll see that this aircraft seems to be in flight because I don't see any landing gear down here. So therefore, the landing gear must be up inside. And if the landing gear is up inside and you got blue sky behind you, this airplane's in flight. At least that's what they want us to think right here. I've always wondered how it could be in flight because if we're in flight, wouldn't this fan be spinning? Of course it would. So this has been a doctored up photo somehow, but this little generator would have a fan on it, and that fan would be in the air slipstream and be rotating. And that little bitty generator right back here would then produce enough power for certain essential items to be powered so that you can at least control the aircraft, get it back down to the ground. If this thing pops out because you've lost all normal ship's power, you're having a really bad day. So get on the ground relatively quick and safe, and park the aircraft. Let them go fix those generators. You never want to fly too long using something like that. Okay. It is electrically heated in flight. Of course it would be, because if that's all you're down to and you happen to be in IMC conditions in weather that's below freezing, you don't want this thing to ice up and quit spinning. It can be manually extended or automatically or manually extended. So if you want to, you can pull a lever inside the aircraft and that thing will pop out. I don't know when I'd want to do that unless I was out of electrical power and it didn't automatically extend. I guess I'd extend it manually. When you get on the ground, there's no doubt the mechanic's going to be looking at it going, uh-oh, something went really wrong with the electrical system for this thing to have to be out and producing electrical power. All right, moving on. Let's go to the DC side. We've just talked about AC power. Remember, what was it? 115 volts, 400 cycles. Remember that. That's a big number for you. What produces all of the power on the aircraft normally? 115 volts, 400 cycles. That's where the power comes from. And how do we get DC power? We convert the AC power to DC power through TRUs. Normally, DC power is provided by 4 each transformer rectifiers that convert 115 volts to 28 volts DC. The other source of DC power is 2 NiCad batteries. These are your NiCad batteries right down in this area based on the schematic. There they are. This is the APU. That starts the APU. This is your emergency backup. I think of this other one as being an emergency. If for some reason I'm out of power, out of AC power, and I got to start the APU to get AC power back, I consider this to be an emergency battery at that point. So power comes down through the TRUs. Are they powering up a DC1 bus here from the TRU number 1? TRU number 2 powers up DC bus number 2 and the DC service bus and DC utility bus. That's what that says there. So likewise, over here, the essential TRU getting its power from the essential bus. Remember, the essential bus is also tied to the ADG bus. That must be kind of important. That's if you lose this, then the emergency generator comes out, powers up the AC essential bus, and it comes over and powers the essential TRU number one. Okay, that must be some important stuff here on the DC essential bus. Okay. All right, so that's basically how that works, moving right along. TRUs, there are 4 TRUs. Each TRU gets power from AC bus. TRU1, TRU2, and essential TRUs 1 and 2. So you can see where they get the power from. We've discussed this already. I'm going to just let you look at that for a second. Ponder the flow of electrical current throughout the system. DC power is provided to the DC buses from TRUs. The schematic right here, that's actually ICAS number 2, showing you that if you selected that electrical button on the synoptics page, this is actually the synoptics page, it's on the ICAS number 2 panel. The DC electrical bus synoptic page displays the TRUs and main DC buses when you select that button twice. So the first time you select it, it's going to show you the AC page. Second time, it's going to show you the DC page. And as you can see, we have AC up here coming in, AC here coming in, and we have the TRUs showing right here. So TRU number 1, TRU number 2. These are basically coming from AC bus number 1 and 2. And then you have the essentials coming from AC essential and AC bus number 2. Okay, powering up all these buses. This shows you that the APU battery has 28 volts available. Main battery has, 26 volts, and the main battery has 26 volts. Two NiCad batteries. We've talked a little bit about NiCad batteries. We have the APU battery, 24 volts, to start the APU, and charges by a battery charger from the AC service bus. Let's go back, just take a look at that. So each of these batteries has to be charged somehow. So in this case, the APU battery is charged by the AC service bus. So if we look at the AC service bus, we're going to see that we have a line coming down here. We have a battery charger right here, and it's going to charge the APU battery right there. Okay. Go back and look at the next one, because it says the main battery, normally 24 volts, nominally 24 volts, is charged by the battery charger from AC bus number 1. Should all TRUs fail, the main battery bus provides power to the battery bus. The battery bus provides emergency power to the DC essential bus. So let's take a look at what's going on here. So the normal 24 volts comes from battery chargers from AC bus number 1. And should all the TRUs fail, then the battery bus provides emergency power to DC essential bus. Let's go back and take a look. Okay, AC bus comes down here, has that battery charger right here, and it's going to charge this direction. Okay, that's good. So we know that the main battery is being charged. If it fails, apparently we can't see it here. There must be another essential bus here. Oh, DC essential bus. So what would happen is this would come up here like this and power this up. Somehow it gets over to the DC essential bus. Let's take a look. Did I misread that? Let's find out. DC essential bus. The battery provides emergency power to the DC essential bus. DC essential bus, I see it right here. Unless I'm missing something right here. Somehow this battery, this bus here needs to be powering. DC essential bus. Not exactly sure how it's getting its power there. Somewhere, not seeing something in the schematic. From time to time that happens. I'm not a genius, so we'll just take it for what it's worth that it has to power the DC essential bus. We do know that it's going to power the direct battery bus for sure. So whatever's on the direct battery bus will also be based on this schematic. Okay, 2 DC PCs, DC power centers. DC power, we talked about this. We saw where they were located, right? They're located up towards the front near the cockpit. You have DC power is distributed through the LDC PC and the RDC PC, a right and a left. The DPCs control contactor relay logic, okay? So it's pre-programmed for certain things. If certain things happen, then certain relays are going to close. During ADG operation, all normal AC power sources, loss of all normal AC power, then the ADG is going to drop out, and then it's going to provide power to the essential TRUs powered. The essential TRU gets powered and provides DC power to the DC essential bus. So let's go back and take a look at how that works. ADG provides loss of all normal power. Let's go back and see. All right. So here's our ADG bus being powered by this. So if we lost all of this, and this, meaning we lost that, and that, we would have to power the AC essential bus right through here. And if we could power that, then we can come over here and come this way and power up our essential TRU, which is going to power the DC essential bus. All right. That's how that works. Back to where we were. So we've talked about that. Now we're talking about one last slide. If I can get it up. Circuit panel. Okay, circuit breaker panels. Where are all these circuit breaker panels located? Now, you know there's a bunch of them. They're not located in front of you like your Cessna 172. Your Cessna 172 couldn't hold but maybe one row of circuit breakers. There's circuit breakers on just about every circuit in this aircraft. Anything to make this thing safe, they will do. Electrical circuits are protected by circuit breakers. There are 8 circuit panels on the CRJ 700. 3 are accessible during flight. Oh my goodness. Okay. Well, there must be 5 more than somewhere else. Due to the large number of AC and DC circuit breakers, the breakers are arranged as in a systematic order. If you were to take a look at this you'd find out there are 3 electrical, there are, let's see, 8 circuit breakers, 3 are accessible during flight. Well, we know that this is a set of circuit breakers that are accessible. This is another set, that's 2. And I'm going to imagine that they've got a set of circuit breakers. Can't see it right in here, but tell you what we can do. We can enlarge this. And there they are. There's the other set that are accessible in flight. I believe that's what those are right there. Okay. And sure enough, because this panel right here is that panel right there. So here's some circuit breakers there and some more. So that's where they come up with 3 circuit breakers in flight. So systematic order, these rows of circuit breakers will have like a letter in front of it and then a number down below the circuit breaker. So if I was looking for A10, I would go to the A row as we've shown here. I'd come over here and that would be A10. So it looks like A10 controls the left windshield. Okay. And so if that popped out, I'd have to ask myself, do I need the left windshield? Certainly not for the continuation of safe flight, because the left windshield is on the captain's side. We don't care if he has a windshield to look out. If you're a first officer, you get to fly the airplane when you're a VMC. So you can see how many circuit breakers are. No, you're not expected to memorize where all the circuit breakers are, but I'm going to bet that the airline is going to want you to know where some of the key circuit breakers are. So that's that. That concludes our module on the electrical system for the CRJ 700. This was part number 2. We reviewed part number 1. Just as a reminder, what is the main source of electrical power on a CRJ jet, for example? You got it. The main source is 2 engine generators, APU, or external power. And when we're right down to nothing else, it'll be the ADG, the air-driven generator, and 2 batteries. So there you have it. That's the complete system. So all I got to say is, I love my job. Glad to be here. Hope I can make a difference.